Okay, so now we are going to be looking at the trigonometric proofs. In this question we have 5 parts, and we are going to be employing just the laws of logarithm which we have just seen to prove or to show these proofs here. So let us see part A. Part A, we have A. We be told that if A is equal to log C base B and B is equal to log base C of A, then we also have C equal to log B to base A. Now we need to prove that A, B, C equal to 1. So this is what is required. Now we know, we have already seen that log of, let me say, x base y is the same as log x over log y, where this is going to be another base. So you can change to another base just like this. Now here I'm just changing to log base 10. So what is here will be in the numerator, and what is the base will be in the denominator. So we understand that. So that is the int on doing this number, because we are going to take, so we shall take ABC. What is A? Now A is log C base B, then times log A base C times log B base A. Because I'm seeing these logarithm interchanging, I had C here, then this is the base, then I had A, then this is going to be the base, log base, meaning that if I happen to change the base to log base 10 in all terms here, this and this and this, we shall end up getting things which are cancelling and expect to get a 1. Okay, let us see what will happen now. So I'm going to change to log base 10. So when I change to log base 10, ABC is going to be, now this one here, we shall get log C over log B, then times, this will be log A over log C times, this will be log B over log A. So I want you to see. So now I want to observe, we have log C and log C here, so this can cancel. Now I also have log A and log A, this will cancel. Then I have log B and log B, meaning that I'm left with a 1 over 1, which is a 1. So that is the answer, and we have proved that. So it was so easy like that. Now let us go to part B. So now here you can see we have got log A equal to x log of B over A, but we are getting it from here. So what can we do to prove that this is equal to this? Now what we are going to do is just manipulate this identity which is given here. You can see that we have like terms here, we have AB, then AB, so we can collect like terms. We bring A's on the same side so that we can subtract or multiply the powers. So here we can have, let me bring A, take A the other side and B this side. So here we shall be having b power x power 5x, then over, now when I bring this b, it will be down, then this will be equal to, then I'm going to take a the other side where I have a to power 5 plus x over a to power 3 minus x. The reason I'm doing this is that I want to get the same base so that I can apply the law of indices. So when the bases are the same, we subtract the power. So here I have b, 5x minus 3x is 2x. Then here we have a. Now we are going to have 5 minus 3, then plus x minus x, which is a plus x. When I get this power minus this power, I get 2 b to power 2x equal to a, then this is 2 plus 2x. Okay, so now you can now see that we can find the square root here. You can see that this can be written as b power x squared equal to a. Here if we factorize the 2 out, we can have 1 plus x, 1 plus x, 2 out. So this 2 can we put out, like that. So of course when you square this, you'll be getting a 1 plus x times a 1 plus x, then the base is the same, we add the power, you get 2 plus 2x. Even this will be bx times bx, base is the same, so you write b, add the power, you get 2x. So here we can now get rid of the 2, we can find the square root on both sides. Square root on both sides gives us bx equal to a 1 plus x. So now what do we need? All we need is now to introduce any log on both sides. If we introduce log on both sides, we can get this power coming down and this power coming down. So when I take log b of power x, and here we shall get log of a to power 1 plus x. This can come down, we get x log b equal to 1 plus x log a. Now we are interested in making log a the subject. We need to make log a the subject. So what we shall do now, I'm going to multiply log a into this bracket, we get x log b equal to, this will be log a plus x log a. So make this log a the subject as it appear here. We shall get log a equal to, then I'll take this one the other side, I'll take it on the other side. No, I will have to bring this one this side because I'm leaving this one to be positive. So this will be x log b minus x log a. So this is going to be log a equal to x. Then what we have here is log. We know that when we get factorized, this will be log b, then minus log a. And this is now the law of division. When you look at this, so we shall now be rewriting this as log a equal to x. Now this one here, log b minus log a, is the same as log of b over a. So this is the proof. So it was simple like that. You need just practice. Okay, so now let us see part C. So for part C, we can see that x is equal to log base a of bc. Now from here we can now write it in an exponential form, and this means that a to power x is equal to bc. Now for the case of y, which is equal to log is b of sc. Now our b to power y is going to be equal to sc. Then for the case of z, which is equal to log of base c of ab in exponential form, that is the same as c to power z equal to ab. Now I have to solve this equation simultaneously while eliminating the a, b and c to come up with this x plus y plus z equal to x, y, z minus 2. So this is 1. Let me call this equation 2 and this equation 3. So now the strategy here that we can either make, if we are to use this equation, remember we need to find out to get rid of the a, b and c when you look at the final proof. So the hint is very simple. You can either make b in terms of, you have to make b in terms of a and c in terms of a. Then when you multiply them, definitely you'll be having the same base and you equate the powers. If you are to use this equation, you can do the same. Make a in terms of b, make c in terms of b, multiply them, you get b power something there, then you equate the powers. All this equation, now we shall be making a in terms of c and b in terms of c, as we are going to see. So now I want you to see that when you look at this equation 1 and equation 2, c is common. So when you divide, you remain with b and a. So I'm going to use this final equation here, meaning I'm going to get rid of, let me see, let me divide, let us divide a, let me say 1 divided by 2. When you get 1 divided by 2, c disappear, so we shall have a to power x over b to power y equal to b over a. And now I'm going to collect like terms. Or if I cross multiply, we shall be multiplying a and ax, that is going to be a x plus 1 equal to b, then this will be y plus 1. So I need now to make 1 the subject. I need to get 1 the subject. But note, when you have x squared and you want a, so when you have a squared and you want a, say a squared is equal to 4. If you want to get a, you find a root, that is 1 over 2, and even here 1 over 2. That is what we do. So here this power, we shall multiply it with the reciprocal, that will be its root. So this is what I mean. I'm interested in finding a. Now if I get a, now that means if I'm to get a, I'll be having a power x plus 1 then times 1 over x plus 1 on both sides. Even the one b would be equal to y plus 1 over x plus 1. So this gives me a as b y plus 1 over x plus 1. So I have that equation. I have written a in terms of b. I have written a in terms of b. So what does it mean? That if I have a in terms of b, I can put it here. Then I need also to get c in this form. C raised to we need to get b, and with this c now we shall get c equal to b and the power. If we get that, then we shall substitute in the second equation. So now remember I have used 1 and 2. Then can I use 1 and 3, or I use 2 and 3? That is a simple question, because now I've told you the idea that we are solving these 3 equations simultaneously. But I have got b, sorry, a in terms of b, but I also need to get c in terms of b, and I use this equation, because I cannot now use this, because now this is going to be c this side, c to power z. Okay, so let me see. So now I want you to note that when we divided 1 and 2, c disappeared, we got a and b, so we expressed a in terms of b. Now I want to get c in terms of b, meaning I need to get these 2 equations which will eliminate the a, and when look at these 2 equations are the one here. So I'm going to divide this and this so that I get rid of the a. I'll be left with c and b. Then I have to write c in terms of b, because I'm going to substitute in this expression. Okay, watch and you see how I'm going to do it. So I'm going to get 2 divided by 3. So when I do that, I get b y over c z equal to, now a disappear, then we get c over b. So now let us cross multiply. This is going to be b y plus 1. It can be 1 plus y, no problem. And this is going to be c z plus 1. But remember, I want to use this equation. I already have got a in terms of b. Then I want to get c in terms of b. So I need to get c. Now c, just like we did here, now our c is going to be b. Then we shall be multiplying with 1 over z plus 1. So this is going to be y plus 1 over z plus 1. That is the c. So if this was equation 3, this is equation 4, this is equation 5. So now I'm on right track, because I have got a expressed in terms of b, and I have got c expressed in terms of b. Now I need to use this expression here to substitute for a and c. Then we shall be equating the powers. So let us see from there. Let me create some space here. by is going to be equal to a. My a, we have b, then we write 1 plus y over 1 plus x times c, and c is b into 1 plus y over 1 plus z. So this was the aim of dividing and eliminating some letters. So what are we having here? So now you can see that now the base is going to be the same. This is going to be the same. We add the power So b to power y is going to be equal to b. Then here we add the powers. This is going to be 1 plus y over 1 plus x plus 1 plus y over 1 plus z. Now when the base is the same, we can just equate the powers. So this will therefore mean that y over 1 plus y over 1 plus x then plus 1 plus y over 1 plus z is equal to y. So now you can say I have got rid of the logarithm and I have got rid of the powers. So the base, the x and the a, b and the c. So we are left with now simplifying this resulting expression until we get what we have here. So now from here what I'm going to do is just cross multiply and transpose, alright, using under the same LCM. So I'll be having 1 plus x as my LCM and 1 plus z. This is the LCM. So meaning that this will be 1 plus y times 1 plus z. Then plus, now this one here will be 1 plus y and 1 plus x equal to y. So let me simplify. So now you can see that when you expand this bracket and this bracket, we come up with this, and the numerator gives us this, then equal to y. So when you look at this, you have z, y, x. I have written x plus y plus z, and I'm seeing it here. Let me first put that in a bracket. Then 1 plus 1, that is a 2. I'm seeing a 2 somewhere there. Then we have xy and yz. So plus xy plus yz equal to, then I'm going to cross multiply. This is going to be, now you can see y will multiply with this, we get y plus z, y plus x, y, then plus x, y, z. When I cross multiply this, now this is equal to that. These two are equal. So we need to check those which are similar. We cancel them. Then you can see we have xy, go with that xy. We have zy, yz, that is the same. Then we are left with y here. Okay, so when I see the y is remaining, could have made a mistake here. Let us check. Okay, yeah, this y should be here. 1 times 1 is 1, then 1 plus times x is x, then y plus 1 is y. We missed out this y, and now y, and this is xy. Okay, so there is a y somewhere here. Let me squeeze it here. So this y will cancel with this y here, and now when you look at that, it means what is left in the numerator in this left hand side is just x plus y plus z, then plus this 2 here equal to, then we can see that in the right hand side you have x, y and z. Let us check here. Definitely. So now you just take a 2. Let me to separate the 2 and the z by putting this dash. So I just take this 2 on the right hand side, then I get my proof. So x plus y plus z will be equal to x, y, z minus 2. Okay, now number 2, part D. We have log base n of m equal to a, and log x log base x of m is equal to b. Here log base n x m is equal to this. Now the real problem is here, so we need to simplify this left hand side. Why? Having a log of n times x is very hard to work with that. So what we need to recall that when you have log a base b, that is the same as 1 over log, then we can interchange and we call this one b and this one a. So we can now make this to be the base and this to be the number which is being operated by the log. So from this it implies that let us consider the left hand side. Now the left hand side, we are going to say to have 1 over this log nx of m is the same as 1 over, then I write log m, and now this will be log what? It will be log n x, log base m and x. So now it doesn't scale anymore, because now this is a product which can be written as 1 over log m, then here we shall be having we have a product, so we shall add. So we shall write log of base m of n plus log base m of x. Hope you can see it. So now we come back from here. Can we get this and can we get this? Of course we can. We can find log base m of n from here. Let us see what happens here. So what we have, we just have log of base what? Of base n of m equal to a. But we need log of a base m, not log of base n. So this implies that we are going to find a reciprocal. So this will be log n base m equal to 1 over a. So we can put 1 over a here. And here we need log of x base m. But what we have here, we have log of m base x, implying, so also here where we have log what? Which is log of base x of m equal to b. But now I want log x of base m. So I just find the reciprocal. This will be log x goes up, m down, and this becomes 1 over b. So from that we just substitute. So our left hand side will be equal to 1 over, now this is going to be 1 over a plus 1 over b, and now this will be equal to 1 over, now this is going to be ab as the LCM, then we shall have a times a plus b, and now this gives us ab over a plus b, which is equal to the right hand side. Okay, so hope you see how we do these numbers. They are very easy, just need practice, just need to know the laws of logarithm. This topic will not give you any problem. All right, so let us go to the last one now. So now let us do the last one. We have log base 3 of x equal to p, and this implies that in exponential form x is going to be equal to 3 power p. We also have log of 18 log base 18 of x equal to 2. This can be written as, in exponential, we shall be having x equal to 18 to power 2. So now look at this equation and this equation. X is equal to this and x is equal to this. So we can equate the two by saying that 3p is equal to 18 q. And by the way, we need to have a log base 6. We need to create a log base 6 on this in our question. So how can we get that? Now let me just introduce log base 6. So we shall get p, then log base 6 of 3 equal to q, and here we shall get log base 6 of 18. This is going to be log, p will come down, and even this 2 will come down. So now you can see that we have now got a log base 6 of 3. So now we can make that one the subject. Okay, but now let us first simplify this. This is going to be equal to 2 into, now this is 6 times 3. So we can write that as log base 6 of 6 times 3 equal to p log base 6 of 3. Now when you multiply, you can just apply the law of indices and just add. So we shall get p log base 6 of 3 equal to q. Then inside the bracket we shall get log base 6 of 6 plus log base 6 of 3. And now from there we can see that this is going to be 1. So 2 times 1 is 2. So we shall get p log base 6 of 3 equal to 2. When 2 multiply with this, we get 1. 1 times 2, which is 2. Then plus, now this is going to be 2 times log base 6 of 3. So we are going to collect like terms. I'm going to make log base 6 of 3 the subject. So let me bring this on this side. I'll be having p log base 6 3 minus 2 log base 6 of 3 also equal to 2. So we can make it the subject here. So this is log base 6 of 3. Making it the subject, get p minus 2 equal to a 2. And if you make it the subject, here we are factorized, so we are making it the subject. It implies that our log base 6 of 3 will be equal to, now the other side we shall be having a 2 over p minus 2. So we have a 2 over p minus 2, and this is shown. So these have been the trigonometric proofs. Very interesting. That is the bit of mathematics. So let's meet in the other video where we shall see another trigonometric proofs, and later on we shall be looking at solving simultaneous equation involving trigonometric proof. You have to look for that video also. Thank you.